Hey guys, today we're going to just talk about graphing sine and cosine functions. Our essential question is, how do we find graphs for sine and cosine functions without a calculator? So we will not be using our calculators to graph these functions. We are going to totally make sense of this using the unit circle. All right. So before we use the unit circle, let's just review some things. Remember, as of yesterday, we said that the x terminal points on the unit circle correspond to and I want to get a thin line, there we go, correspond to the cosine values. Okay, so we go to any angle, okay, whether it be in radians or degrees, and all of the x values are the cosines at that angle, right? And we know that the y corresponds to the sine values on the unit circle. So we go to any angle on the unit circle, whether it be in radians or degrees, and the y will be the sine value at that angle. Okay, so the y terminal point is going to be the sine. And this is exactly what we're going to use to come up with our functions. Now, if we take the y divided by the x, it's going to give me the tangent at that angle. Okay, it'll give me the tangent. Today, we're going to focus on just graphing cosine and sine functions. And what we're going to do is we're going to use the values from the unit circle at our special angles to come up with the graphs of y equals sine of x and y equals cosine of x. So let's start with y equals sine of x. All right, so what I'm going to do is I am going to just go around the unit circle, and what I'm going to do is only focus on critical angles. So these are going to be my angles at each quadrant. So I'm going to start with 0, and then I'll go to pi over 2, and I'll go to pi, and I'll go to 3 pi over 2, and then I'll stop again at 2 pi. Okay, and so again, these are the quadrant angles. Now, I want to go backwards, so I want to get the negative side of this graph too. So I'm also going to go in a negative direction. Notice I have negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Remember, if we're going in a negative direction, we just start at 0 and we move down. So right here, coterminal with negative pi over 2 is our 3 pi over 2 angle, right? We go down. And then if I want to go to negative pi, I move this way, and negative 3 pi over 2, I go this way. All right. But what we're going to do is I'm going to only grab the sine values. So my x values are going to be the angles. My y values are going to be the sine at those angles. So let's go ahead and find those sine values first before we graph. So if let's start here in the positive direction. Let's do that. And I'll go back. All right, let's start in the positive direction. If I am at 0, okay, and I need to grab just the sine value at angle 0, the sine value is that y value. So the sine at angle 0 is going to be 0. And then if I go up here to pi over 2, the sine at pi over 2 is going to be 1. It's the y value. If I go to pi over here, the sine value is the y value, it's 0. If I go to 3 pi over 2, and I'll move this over, 3 pi over 2, the sine value is the y value, it's negative 1. And if I go to 2 pi, This sine value, of course, is coterminal with 0, so it is also 0. Now let's move in a negative direction. If we moved in a negative direction and we started here, right, we went to negative pi over 2. Remember, we would be going down, okay? So we're going clockwise. So negative pi over 2 would stop right here. So its terminal point is the same as 3 pi over 2. So the sine value would be -1. Negative pi, we go around a whole distance of pi, but in the opposite direction. So negative pi, the sine value is going to be 0. -3 pi over 2, go all the way around, and we would stop here, right? So the sine value, or the y value, would be 1. And then -2 pi we go all the way around and end up where we started. The sine value would be 0. All right, guys, so we got our points, and now what we're going to do is we are going to graph y equals sine of x. Okay, so we're graphing sine of x. And remember, our x-axis is going to be the angles. And our y-axis are going to be all those sine values. And so let's go ahead and just plot our points. So my angles are going to be at 0. And then I got an angle at pi over 2. I'm going to go the positive direction first so you can see what's happening. And then I have an angle at pi. And then I have an angle at 3 pi over 2. And then I have an angle at 2 pi. All right. And so then let's plot our points. Okay. This at 0, I'm going to be at 0. And I'll change the color. So I got a dot here at 0. At pi over 2, I'm at 1. At pi, I'm at 0. At 3 pi over 2, I'm at -1. So I'm right there. And at 2 pi, I'm at 0. I'm going to do the same for the negative side. Okay, so for our negative side, we would have -pi over 2. -pi. -3 pi over 2. And -2 pi. And then we're just going to plot all of our sine values. So at -pi over 2, we're at -1, which is right here. At pi, -pi, we're at 0. At -3 pi over 2, we're at 1. And at -2 pi, we are at 0. All right. And let's just connect it. And notice when we connect it, this is the graph of a smooth continuous curve. All right. And this is what we call a periodic function. Notice it just keeps going and going. If we were to continue to go around the unit circle, round and round and round, and we kept getting sine values for angles, because remember, we can continue to do that, we would continue to get this smooth continuous curve. Notice the curve starts at 0, and if we move in a positive direction, it goes down and it stops at 2 pi, and then it will repeat and do the same thing over and over again. This distance we call here, where it does its thing before it repeats again, is called the period. And how high the graph goes is how high up the graph goes is called the amplitude. All right, so we're going to fill in some characteristics on the graph on the next page, and then we'll come back and we'll talk about graphing cosine of x. All right, so let's look at some characteristics of this graph of sine of x. Some of the characteristics that we need to know for the graph of sine of x is what the domain is. Now remember, the domain of the sine of x is all of the x values, and remember it was periodic, so that means it's going to continue to do the same thing over and over again. So it is going to cover the x-axis completely because it just keeps going and going and going and going. So we know the period is all reals, right? It's all real numbers because we can have an infinite amount of angles, right? So it says over here we can find the sine of any angle measure. Now if we talk about the range of the function, this is the y value, how high up it goes and how far down it goes on the y-axis. We know that the sine only went as high as 1 and as low as -1. So our y value is from -1 to 1, right? Now the sine is going to be an odd function, okay? Which means that the symmetry for sine is going to be around the origin. The sine function's period, we talked about the period, or how long it takes to do its thing, is going to be 2 pi. And after that, it'll repeat itself. Now, what I want you guys to do is I want you to look at what we graphed. So you're going to go back. I want you to look at what we graphed, and I want you to fill in 5, 6, and 7. Tell me what the x-intercepts are for the sine graph, and I want you to list 4, and then I want you to tell me what the y-intercepts are. The y-intercept is, sorry. Tell me what the max is, and remember there can be a lot of maxes. I want you to list 2, and tell me what the min is, and I want you to list 2. Where does the min happen at? What angles do the min happen at? What are those x values? And how high does it go? All right, here's your hint. Okay. All right, guys, this is now the graph for sine of x, and we're going to move on and we're going to talk about the graph for cosine of x.